A well-insulated rigid container of volume 1 meter cube contains 1 kilogram of ideal gas whose specific heat capacity at constant pressure is 1000 joule per kilogram Kelvin, and CV, that is specific heat capacity at constant volume, is equal to 800 joule per kilogram Kelvin at a pressure of 10 to the power of 5 pascals. A stirrer is rotated at constant RPM in the container for 1000 rotations and the applied torque is 100 Newton meter. The final temperature of the gas in Kelvin is, so we know that work done, the rotational work done is given by torque multiplied by the angular velocity. Okay, so torque is 100 Newton meter multiplied by angular velocity, which is 2 pi into 1000, right? Because it is rotating at a constant RPM of 1000 rotations. So this will be equal to, now if we want this value in kilojoules, so we will just divide it by 1000. Okay, so this will be 628.32 kilojoule. Now from the ideal gas equation, we know that P1V1 is equal to mRT1, okay, where 1 represents the initial conditions. Now the initial pressure given is 10 to the power of 5 pascals into volume, which is 1 meter cube, is equal to 1 kilogram of ideal gas, so 1 into R. We know that R, the gas constant, is the difference between the heat capacity, Cp minus Cv. So Cp in the problem is 1000 minus Cv is 800. So this will be 200 into T1. So from here we'll get the value of T1. So T1 will be equal to, so 10 to the power of 5 divided by 200. So this will be 500 Kelvin. Now from the first law of thermodynamics, we know that the change in heat delta Q is equal to the change in internal energy plus the work done. Okay, so this we know from the first law of thermodynamics. Now since delta Q in the problem is 0, okay, it's given because the container is fully insulated, and also we know that du is equal to Cv into dt, change in temperature. So we can write the work done delta W is equal to Cv into dt. Work done is negative because the work is done on the system. Okay, so work done is negative, so this, let's write here, this is negative. Okay, so we can write like this. So from here we can calculate dt, that will be delta W divided by Cv. So delta W we have already found, that is the work done by the stirrer by rotation. So that, let's write here delta W, this will be delta W. Okay, 628.32 divided by Cv, which is 0.8. So this will be equal to 785 Kelvin approximately. Okay, so since we know the temperature difference, this is T2 minus T1. So T2 minus T1, we have got 785 Kelvin, and we know the value of T1, so we can find T2 will be 785 plus 500. So this will be equal to 1285 Kelvin. Okay, so from here we can say that option D is the correct choice, 1285.4. For more information, you can refer to the NPTEL course, lecture number 19, Properties of Ideal Gases on Basic Thermodynamics by Professor S.K. Som of the Department of Mechanical Engineering at IIT Kharagpur.